This is gonna be a somewhat relaxed stream. I don't know how long I'm gonna go for, since I'm very tired, but also eager just to do at least a bit of work on the project. Yeah, so the last time we ended up doing a lot of preparation in terms of uploading textures to our GPU. We actually succeeded in a way to upload data after a lot of trial and error. What you saw in the last stream was me doing a lot of experimentation on how to structure things. It didn't really work out. So yeah, we instead ended up just increasing our linear buffer size and allowing it to at least contain the full texture and then uploading it. Perhaps I'll increase the buffer size even more later on. All right. Next, we have to do what is called. Yeah, actually, we have several steps that we need to do textures. I made a short to do here. We need to create a view slash descriptor on our descriptor heap and bind it, or rather create some descriptors and bind them to the descriptor heap. And then we need to create a table of resource views in our root signature and also so-called static samplers in our root signature. We already have our descriptor heap. I even think we use it. Excuse me. Yeah, I think we use it for some. No, we only use it for the depth stencil view, but it supports something different than depth stencils. So yeah, we don't need to create it, but we would like to allocate a series of descriptors to our textures, which are called SRVs. Is it structure or I think it's structured resource view. Let's see. Shader resource view, of course. Well, close. So yeah, just a sec. I'll just do some short things here. There we go. So yeah, we could do separate pipelines, which we aren't going to do. Or will just contain the information, even though we do have at least two pipelines that don't need these root signature details. So yeah, we could do we could do what do you call it? We could do separate root signatures. I think we will add it to some optimizations. Separate root signatures for different pipelines. Different shader bindings, different static samplers. Yeah. That's something we could do in the future. But as per always, we will prioritize getting something up and running. Right now, our second pipelines are drawing line-based stuff, which we use for debugging. So I'm unsure whether we actually want to use that pipeline once we're done. So yeah, right now it's not a priority to do different root signatures and so forth. Let's see. So we need a descriptor range, or yeah, let's do that. So we'll add a new parameter. Parameters. Apparently I can't spell. This will be of a type D3D12 root parameter. Oh, I'm sorry. So far it's been a long week. Let's see. I even missed that. This is the correct thing to say it. We want it to be visible for all. Shaders, at least for now. Man, this annoys me. Number of descriptor ranges is just one. And then we need to give it a pointer. to the actual. Let's see, we set it to null pointer for now. Parameter ranges. Let's see. Buffer overrun because I haven't increased the. Now I rename them as well. There we go. Next we do some D3D12 descriptor ranges, and of course the one type, since it supports a shader version or root signature version of 1.1. Not that we are entirely sure we need it. Okay. Let's specify our first range. Range type is gonna be a D3D descriptor range is SRV, because we want to point to shader resource views. Right now we only have 2 textures in our pipeline. Maybe we want 3. I don't know. Nah, let's just do 2 right now. And I prepared some textures for this episode. Then we do the base shader register. It's gonna be 0, and also the register space. So this will start with T0 with no register space specified. It's not gonna have any flags. Let's see. And then we're just gonna append it. Let's see. Offset append. There we go. So now we pass in the reference to our range. Let's see, it's not supposed to be referenced. Well, it's supposed to reference the base range, since it's an array of different ranges. Yeah. I think this is the correct way to do it. Then we need to, so that was basically part of this. We of course need to bind it to our pipeline. Yeah, but we will get to that eventually. And then we do some static samplers eventually. Let's see. The 3D12 static sampler description. samplers disk. Yeah, and of course we do an array. Let's see, we would probably like to set up some samplers here. Set up some samplers. Let's look into the different static sampler, DirectX12. Let's see the filter. The filter for the sampler can be set like this. I think we would like something fairly cheap, meaning a minimization, magnification, MIP-based point sampling. And we could also do some anistrophic anistrophic filtering. It's more expensive, but we could try it out, see if we see any differences. Yeah, that's definitely possible. You could do a lot of the different static samplers, so yeah, you actually don't need to worry too much about it. I can't remember how many static samplers you're allowed to create, but for a small project like this so far, you will probably not end up meeting any problems. Yeah, let's just do a couple of point samplers and some aniostrophic samples. Samplers. Oh my god, I'm so tired. I'm sorry. I'll be stumbling over my words. So we would like one with an rep address mode, and we would like one with maybe a clamp. I actually think I would end up using, well, there are different advantages doing yeah, we definitely need one a rep, at least for our current textures. So yeah, let's set up a rep sampler and um, and let's see, a I don't know if we want a clamp. Let's see, is it prefaced what did the documentation say? Yeah, it does. It's prefaced with the 3D filter. We could do both point, linear, and then aniostrophic filtering and test out the differences. Yeah, we'll do that. And then we will just do rep. Since I need to copy this so I don't have to paste type it every time. Then let's set the address mode to rep. Address mode to rep for each axis. There we go. So now we have most of our options set here. So yeah. So we can offset in terms of the mipmap levels, which you, if you recall or watched any of the previous episodes, is somewhat downscaled textures based on the original. If DirectX12 calculates that a texture would be sampled at mipmap level 3, if we offset it by 2, it will be sampled at an even lower MIP level. Let's see. We do just a offset of 0. We don't want offsets. Let's see. We do and min LOD of that. We do that. We could look up the DirectX12 helper static samplers and see what they set up. Let's see. Default sampler. Oh well. DirectX12 help us. Where is the GitHub? There we go. Let's see. We look up the source code. Samplers. Whoa. There we go. Headers. That was the one I was looking for. Statics. Root signature. Let's see. Where's the function? Doesn't contain any static samplers. There should be a helper for it, as far as I know. Oops. There isn't a version that shows you the static, rather standard static samplers. Pipeline stream, checks to forward, core maybe. Static samplers. God damn it! Sorry for all the dinging. Static sampler helper function. Does it? There we go. Does it say which helper file it's? It's just okay. Created in the base. Whoops, the base header. So, okay. Well, doesn't seem like it. Then we just end up not structure. All right. Sorry for the hold up. Yeah. Let's see. Not there. Root signature. Does it? Yeah. Yeah. Okay. Well, we were correct in going into the root signature header. So it inherits from, takes the shader register, sets it as wrap, and sets it default to 16. Does it have any specific presets? No, it doesn't. Yeah, let's just use something like that. Uh, let's see. Yeah, I'm actually unsure which comparison function to use. I see here that whenever you just specify the method and the address, the default values for the helper. Let's see. Let's do 16. Just and whoops. Whoops. We do D3D float 32 max. For the max, D3D12 float 32 max. Let's see, comparison function. Yeah, we're gonna change this to pass always. and then we can always change it to other methods down the line. Let's see, we set this to 1 since it's not anisotropic filtering anyway. Do we set it? Oh yeah, shader visibility, of course. We could do pixel shader, but let's just do all. We add the comments. Try not to forget it. The register space is 0. Let's see. Are these optional? No, they are not actually optional. So shader visibility, shader register. Let's just do this as number 0. Shader register. This will have the register S1 space. Is it called subspaces? I can't remember what the prefix is. Anyway, so we have our filter, address modes, MIP LOD bias. Do we have that? No, we do not. Let's just set that to 0, 0 and look up what it actually does. Offset from the calculated MIP map. That was what we were discussing earlier. The minimum LOD. Yeah, so you can offset. Oh, okay. Yeah, this is in terms of which MIP map to use. Yeah, I think we got everything set up correctly then. I think we end the function declaration with these 3 parameters since they are nice to be able to find. Then we would also like, let's see, let's do a linear one. And we set the last one to anisotropic. And let's set this to 16. And let's set this to there we go. I think this is fine. Let's see. Do we compile? We compile and we run. So far, so good. So we got a setup with the samplers. If you know what I mean. You probably don't, but it's quite alright. It's quite alright, my friend. Yeah, okay. So we did some static samplers. Let's see, we would like then in our shaders to bind some samplers to our pipeline. I'm pretty sure that we will only use our samplers in the pixel shader, which could be an argument to. Oh, where did the mouse go? Oh, there. I'm sorry. You have to bear with me today. I'm so exhausted. But now I will stop complaining about that. So yeah, we bind our samplers by typing in an object of a sampler state and let's do point rep and set it to register 0, 0. Does that correspond to what we just did? So we did linear, point, linear, aniostrophic. So, and they are all rep. There we go. There we go. Let's try that. We do not get any errors. Great stuff, great stuff. So yeah, we actually need one more thing. Load UV coordinates, which are texture specific mappings into our vertex buffer. So yeah, we need to do that. And I even think there is a semantic HSL texture coordinates. Let's see, we do texture coordinates as our semantic whenever we load the vertex buffer information. So for our base pipeline, which will take the UV coordinates, we would like to do the what did it call it? Text coordinate, and it's only gonna be 2 components. Therefore, we do like that, and it's gonna be 8 bytes. And this should compile fine, right? Yeah, it probably no, it doesn't complain yet. Okay, it accepts it. So now we can, in our render data structures, we can do a normal vertex here where we do a GXE float 2. It's not aligned. No, it's not. UVs, which we do like this. They're only X and Y coordinates in terms of where to sample the texture from. And then we would also like our object data to have some texture texture matrix. Let's see, because we would like to transform our textures. Let's see. Let's see. We could call it text transform. Yeah. Yeah. So far, we probably will still compile fine. Yeah, we do fine. Our system is robust enough to handle these changes. Then inside our shaders, we have some shared information, which we're not gonna alter. Then we're gonna change the input, and we will add our UVs and do text coordinates. For that, we will output them once again as just trans. Nah, we will just pass. Now we will transform them by the world view projection matrix to get clip space coordinates, homogeneous clip space coordinates as we do everything, meaning that, let's see here, we do get a warning. Yeah, we have not fully initialized it, so it's not complaining that we actually use the value. It's right now it's treating warnings as errors, which will make sure that our shader code is tight. But yeah, usually you wouldn't get a crash from that. Let's transform the text coordinates by multiplying the input UVs by, and of course, since we do matrix multiplication here, we need to make sure that the vector that we multiply the matrix with is a vector of 3 coordinates and then a 1.0. Let's see. We only have x and y's, and therefore these values are. Let's see. No, we do not transform it by world space, but actually by the texture transform. So let's see. World T. Yeah, we didn't specify anything here. Let's see. I don't think we actually need this. I think it was just for debugging, right? Let's see. Text trans. Let's see. Multiplied by the text transform, and then set the output UVs as the x, y coordinates of this. Since we would like the transformation. Invocation is ambiguous. Hmm. Let's see, does it give us any errors? Uh, okay, there's something about our constructor here in terms of the yeah. Whoop-de-doo. A little typo. It happens. All right. And we copy and paste that in. We do not have any problems. Then we need to set our let's see. We need to create a float for called diffuse albedo, which we haven't used yet, which is going to be our, let's try, uh, the sampler state doesn't have the method sample. Why is that? Huh. Let's see if we, for now, move this. This is not supposed to change anything. But let's see. Sampler state does not have method sample. Huh. Let's see. Do we have sample? Let's see. Sampler. What does that mean? Sample. Let's see. What happens if we just say well, no, 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 no. This is because I'm not supposed to use this sampler. I'm supposed to use the texture, which I haven't bound yet. All right, that is why. So we have a texture 2D. We could do array. I think we have support for texture 2D arrays. Yeah, we could do that. I think it's supported. But yeah. We could perhaps do that. Yeah, we could do that. But yeah, do we really want to do that? And let's add a global specifier for that. Register T0. Yeah. Texture bound to pipeline. Then we can do our diffuse map sample sampler state. Let's try the point wrap, at least for now. Then we have the location, which is going to be our input, the UV, I think. And is that actually correct? Yeah, it is. At least it doesn't complain a lot. Yeah. So this samples our texture. Right now we do not see any change because we have no input in terms of our UVs. Let's see, let me just swap back and forth just to see if the sampling actually does anything. I'm pretty sure it won't. Visually, no. No, it doesn't see. Maybe, though the edges are a bit sharper. I don't know. Anyway, I don't think it makes a whole lot of a difference. All right. Now we need to load the UV coordinates into our renderer. Whenever we create the static meshes, we would like to process, so the vertex has UVs. Let's see. First, I would like to test out that we have some UV data. We actually do not have a method activated for it yet. Let's see. just inline. We load up the UVs, and I would just like for debugging purposes to print out number of vertices, vertex data dot size, and number of indices. Yeah, okay. Normals. Normal data get size, or rather, like that number of UVs. UV data gets get a size here. Let's test that out. I just want to make sure that our yeah, it corresponds. So my wonderful homemade mesh loader still works completely as intended. UV data, and then the vertex. There we go. So now we upload the vertex data. So now we need to create a view to our texture. Great. We also need to create a renderer structure. We could eventually do some heap managed stuff here. All right. Let's just CSU heap, meaning constant buffers, shader resource views, and unordered access views. And we do a let's see, what is the method for it? We initialize it, and we pass in our device, and we create a descriptor heap for that. We would like it to be size of 1, and we would like it to be shader visible. Then we ask our device to create a shader resource view. We of course need a description, and we also need to pass in our texture test. So it is for this resource. Let's just comment this out. D3D12 resource descriptor. Resource description. Is that? No, that's not correct, is it? Let's see. Shader resource view description. There we go. Text view disk. Let's see. Let's see. Data component for mapping. This is just standard stuff. When you look up the structure, like this, most of these things will get specified. Yeah, you can change the mappings of the components. We really don't want to change anything. Let's do I'm unsure if I'm actually supposed to store this in memory and keep it alive. Well, we will find out. We will ask our resource to get our description and its format, or rather like that. What's the next component? The view dimension. It's gonna be a text 2D, baby. There we go. The buffer pointer, then whoops, view dimension. So first we have format, buffer, that, then, or rather, format, then the buffer. Whoops. Buffer equal to that, get it. Let's see, do I not need to specify that? Whoops. I'm getting into the union here. Text 2D. Yeah. This is wrong. Most detailed MIP. It's always currently our first one. There we go. And the MIP levels. Let's just let's get this from the get description, MIP levels. Plain slice. I don't care about that value. Let's see. Does this hold up then? Text view description. And then the MCSU descriptor. Oh, CSU. Let's see. Get CPU handle. Let's just start with the 0 here. Yeah, it's the CPU handle. There we go. Let's try that. Oh, we do have to set the plain slice. Although I said I didn't care. Is it 0? Yeah, it is. That's what you get for not initializing. Okay. Last but not least, we could try binding it to our pipeline where we have the fourth parameter as our resource. Am I supposed to set format? No, 3 or 4. Yeah, this means fourth component, right? And MCSU heap. Get GPU handle, and we do it for that one. Let's see. Wait a minute. There we go. I think. So it takes the GPU virtual address. It's because I have to bind the, I'm using the wrong thing here. Set graphics descriptor table base descriptor, and there we go. There we go. This should be fine, right? Oh yeah, we need to bind the descriptor heap as well. Descriptor. One, and then our MCSU heap. Just read one. I think this is all right. Uh, 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 let's see, is there another one? Descriptor. Let's see if we change it to a hard-coded array with only one, where we set it to MCSU descriptor heap. Let's see. Pointer to a pointer. Maybe two. Let's see. We would like to know what is up with this. And we do like this, and then change. Mm. Let's see. So let's see. Whenever we is it because I have to store the view? Maybe I have to store the view. Maybe it gets invalidated. Let's see the locals. So that one is actually. Let's see if I. Let's see. This is absolutely not correct. Hmm. Maybe I need to do like this. Reference that. Or rather get the address of it. There we go. Yeah. I think they were incompatible types. Let's see. Let's just do like that again. Maybe just one here. There we go. Right now we have no crashes. We have everything up and running, I think. At least somewhat. Let's see. If we compile this and export to NVIDIA Insight, update our shaders, because we have to do that before we boot NVIDIA Insight. Texture and shaders. I'll just copy that over and replace the files. So we have a texture, which is pretty fine. Then we do some descriptor heaps. Descriptor heap. Yeah, so we actually do bind a descriptor heap here to the specific texture. Hmm. Let's see, I want some debugging here. Whenever this gets created. Pass buffer data gets it. Yeah. Material buffers gets it. The vertex buffers gets it. Let's see. Get set name. Object data buffer. There we go. Let's see. Object data buffer. Let's open that. Do a 4x4 float. 4x4 float. Let's see. Object transform data. Object data. Yeah, okay, so it automatically copies something that is wrong because it copies the next object's uh, information from memory. So that is why nothing is behaving correctly. So let's do object transform, or rather, the do we whenever we do the transform, let's see. World matrix. And then we would like to create a yeah, we would like to create a identity matrix. Let's just do that. Temp matrix, texture matrix, math get identity matrix, and then mem copy that in as our let's see, plus the size of that must be a object to a complete type, so we need a byte pointer, which we increase by that size, and we actually give it the memory address of that matrix, and we do the text transform. Thereby we should be able to this is not going to work, or what? Let's see, what does it complain about? Warning, 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 warning. One failed. Warning. Message warning, warning. Warning. Huh? Show me the error. Could not open. So we didn't have a problem in terms of that. And we had to look for it, but do you see? Our texture actually does get applied here. Now, isn't that great? We told the basically we have two problems here. I think inside Blender, I'm unsure whether we actually have exported anything since it's both flipped and yeah, upside down is not, it's mirrored. Uh, and also flipped. So if we mirrored it and turned it 180 degrees, but yeah, we do have textures now. Or rather, if it got flipped uh, over the horizontal line. So yeah, it's somewhat upside down. Did I ever export the models again inside Blender? Let's see. Let's see. Let's test that out. Open, reset, break wall. And if we export that as wavefront, into our, no, not that, into our models, break the wall, and we triangulate the faces. If we do like that, does it change anything? Nope. So yeah, if we export it with the -y up, I decided that we would start with something like a simple Doom clone. And welcome, by the way. Whoops. Oh, I forgot to check what I told it. Yeah, so -y up. Okay, it did the same thing. And did we get the right folder? Maybe. Let's see. Okay, now it's just rotate it the other way. So yeah, we can flip it once again by taking it like this. I'm building my own engine. I'm not using an engine. I've built everything from scratch. Thank you. Yeah, but yeah, maybe I should put it into the title anyway. Let's see if I do -c -y. Do we get the correct orientation on the texture then? Not totally. Yeah, this might be because of the way I do the view matrix. Oh yeah, it doesn't really matter, that one. Let's see. What about the other sides? They're all flipped. Anyway, that's not the texture I want to use. Anyway, I already preloaded something else, which we are going to use here. So I created a texture called brick, which will be this one. It's just a part of the royalty-free texture database. We will tell the renderer to load that instead. Let's see. So we set it to brick. Now I think all object, yeah, as you can see, we do get some objects here. Or rather some bricks on the wall. The next thing I have to change is the way the reflections on the material work, because it looks horrible right now. So in our application, when we create our walls, we have material number 3. So whenever we number 3 here, we will make it reflect whatever texture color is on the texture. It's not gonna be very reflexive, and it's gonna be fairly rough. So yeah, that looks better at least. Maybe we need to tone down this. Let's see, does this change what we want to change? Or is it my shader? Does it apply? Yeah, it even applies it to the floor, because right now we have not created a separate texture for that. Let me just disable the lighting, excuse me. Whoops. Yeah, okay, I can't just do like that. I need to, inside this shared, disable the lights like that. Okay. Do I have to change? Let me see. In our application, yeah, I need to enable that again, of course. All right. So it's definitely something to do with our lighting. Right now we're stretching the texture and filtering it in a sort of bad way here. Doesn't look nice at all. And right now we handle all objects equally. Let's see. We could do separate textures. Yeah, but right now I don't want to work on that. Let's see if we turn down the strength of the lights here and enable it again. Does it still look horrible? Let's see. I need to go into the shared folder, yeah, and enable the lights. It does look better, but I'm not sure that this directional light is something that we want. The roughness could perhaps be like that. And we have okay, that definitely didn't help. Let's just turn it off. The Fresnel still doesn't help a lot here. I'm just gonna play around with the material details here. Well, is it because I set the roughness to such a high level? I guess. But the walls are not supposed to be shiny. Let's see, and maybe I need to adjust the strength of the light a bit down as well. All right, and let's try a different sampler. Instead of point wrapping, let's do the supposed to be prettiest one, and strophic filtering. Yeah, things got sharper now. But we're really overstretching that one, and I don't think the look is great. So yeah, we need to expand the system to handle specific texture matrices. So I'm gonna move this one out and change this to object transforms. Or rather, no, let's just set the system up so that it is able to handle individual texture maps. So our renderer already has a data structure that holds the object data, which is both the world matrix and texture transform. Our system holds some no, game objects. Yeah, so game object data is arranged in these data structures. So we could set an texture ID, and we could do a struct called texture transform, which will be a separate thing. Our application, which holds all of our data for now, will store a vector of these data containers. So we will do texture transforms. Yeah, I know this is very temporary and not very neat way of arranging our data, but it will get things up and running. We do some textures here. Whenever we create our game objects, we do their transforms. We could do their textures before and after. I would rather do each object's texture down here. Set texture mappings for each texturized object. So like this, we do do manual mapping of each texture for each object. So this is going to be 0, this is going to be 1, so forth. We also want to set the object texture. Since it's our floor, we would like for it to be the first texture. Doesn't really matter. Right now we only load the wall texture, which means they are basically the same. Then we load our walls here. Yeah, I'll have to change some of this code, or rather, the underlying code. Let's see. Let's do a texture transform, temp transform, and we could just copy, and this, it's already set to a baseline of a identity matrix. Let's see. This is the positioning that we don't want to change that. We do want to change the scaling. Let's say we will try 4 times scaling. Let's say this is the floor texture, and then for the next 4 walls, we do wall segment -x, wall segment +x. I think this is our long pieces, aren't they? Yeah, they're scaled by 4. This is scaled by 1 and 2, I think. Yeah. And we have the -c. Whoops. Oops. I somehow copied empty space, which theoretically probably is the easiest thing to copy. Let's see. And we want to take our texture trans and in place that texture transform. Yeah, and we would like to do it for our wall. So this is probably going to be scaled only on, yeah, maybe, no, since it's the UVs, I won't be scaling anything except for the X and Y. Let's just play around with this. Set it to the same right now. We'll change the values later. Okay, so now we have 4 separate texture transforms, but we don't do anything with them. We only hold them in memory. Right now we will not use this because I will load the textures manually in the renderer by extending the initialization code here. Up here, yeah, in our test area. So, let's change our renderer. Let's see. Sorry, I'm really tired. I was just losing my train of thought. Yeah, so we do a internal vector in the renderer, which will hold our textures. Yeah, so we will disable that, and inside our render, where when we load our thing here, we resize by giving it a size of 2, which means that it just calls the empty constructor on each D12 resource and then we can actually use those two. As you can see here, it registers the object fine. And let's see here. Yeah, this code would have to be abstracted away and somewhat cleaned up, but right now I think this should be fine. Yeah, everything works still as intended, but we have no scaling yet because we haven't implemented it. So now we load that texture. We could load it into the first one, and then what did I call it? Did I call it tiled floor? And then we use that. Now it will be everywhere. Oh, let's see. Oh yeah, I don't need to redefine the loader. We could also do something that probably looks a bit cleaner here, like that. Oh yeah, I'm reusing the same memory here. Doesn't work that way. These two should also be each of their own. Let's see. Yeah, we definitely need to abstract some of this away because it looks horribly messy. There we go, everything still works. Let's see. But we do not actually... I don't think that is the way it's supposed to be. Let's flip these again. Yeah, it only loads that one. Either I created the wrong texture when I did the textures and that is the bug, or the bug is somewhere else. Let's see. We do the upload. Let's see. If I open the tiled floor. No, it does really no. So maybe we're supposed to upload like that. Oh yeah, it's because I'm an idiot. I'm so tired. Sorry. It's because I'm referencing these two data structures and I'm not referencing the second one. If I just change this to 2, this wouldn't even matter because this one would get overwritten by the contents of the child floor. Or am I being totally wrong here? Oh yeah, because we haven't loaded anything, I think. And we actually queue the upload again. Yeah, okay. There we go. As you can see, everything gets changed. So the problem is my coding here. So this is probably gonna work Yeah, now, and we can set this as 1 instead, and then the floor will be bound to all of them. Yeah, everything works as intended. Anyway, let's create 2 descriptors on our heap, and let's do, since we use all values here, we could just redefine them afterwards and do like this. And then create another scripter and bind it to this texture. This is not gonna make anything look different, but now during our draw calls, we can actually change what texture is bound to the pipeline, and thereby by changing one value inside our draw call here, we can let's see, yeah, we can change the texture. Yeah, as you can see, we can just flip it like that. Yeah. So far so good. So now we have 2 textures in our, which we are able to bind to our pipeline. Then our data structure here, which is the actual render items, which handles which texture to show. It will have a texture index, which will be -1 at default. Then whenever we render, instead of doing it outside each draw call, we do it inside, combined with each draw call. Our item will then be asked what texture index do we want. Right now it's -1, so this will probably give us an error. I'm pretty sure, yeah, it's supposed to, because the -1 doesn't exist. We have to set it at least as, let's see, we do that during submission, but here we could do it just manually. Item data, texture index, right, is equal to our game objects, and the previous set texture index, which for our objects here were 0 for the floor, which is actually the opposite of what we did up here. Yeah, so let's just flip these otherwise. Or yeah, and that's a lot of places that I need to get everything right. It's far easier to do it the correct way out here. Doesn't matter which order the textures are loaded in, as long as we reference the correct ones. So does this work? Yeah. As you can see now, our floor has a different texture. Our walls have the brick texture, and the floor has the somewhat tiled floor-ish texture. We also need to update the material of our floor, because right now it's very, very green tinted, and we would just like for it to use the texture as it is. It's supposed to be somewhat rough. There we go. Next thing is the actual scaling of the textures on each surface, which we started implementing down here, but we haven't actually passed into our renderer. right now this is in terms of static objects, which means whenever I spawn particles, maybe I would actually like for 0 to be a placeholder of sorts. We will have to do that eventually. Let's just set this as 0, because if we do not set it, we will have crashes. Let's see. And the submit here is also gonna need to take in the texture injects, otherwise we will have a crash. And there we go. Now we can spawn particles. They will have brick texturing, but yeah. I think yeah, maybe we will do a texture that is all black or something. All white, maybe. Yeah, that could be a way to do it. Anyway, I wanted to let us pass in our texture information, so I need to update the signature of the preload static methods object, or rather method. Let's do texture transforms and pass those in. Textures trans. There we go. And then inside our application, which calls this function, after our materials, we will do our texture trans. This is probably going to compile, even though it doesn't do anything. Yeah. Then for all static objects, well, that is also a problem whenever we do the particles. We just have to remember to set that up. So whenever we create the texture matrices, we could, instead of doing like that, we will do the texture trans index by that and copy over the transforms. And yeah, and since we only want to, yeah, we don't need to change the dynamic renderer uploader. Oh, now we're getting something. Oh, somewhere. Not something. We're not getting anything. But yeah. Yeah, the large ones are probably gonna be scaled twice as much in terms of the X. Uh, let's see, let's see. The texture transforms for the negative X, positive X. Let's double the X scaling. Whoops. That looks better. And here on the floor, let's double the both the X and Y scaling. Well, well, it is something. Let's see. So yeah. Maybe we enable the lighting again and get weirded out by the weird. Oh, we already enabled the lighting. Maybe it's because I toned down the intensity of it. Is that better? Well, yeah, the floor is probably pretty shiny, isn't it? Let's see, the floor is material 0. It's just law. And I think this one, material 3, is the wall. So yeah, let's do like that. And inside our pixel shader, uh, let's see. So yeah, that's a lot of ambient lighting. This is the way um, our textures really look. Probably looks not very pleasant. Let's see if we do like that. Let's see. Well, it's not flattering. And then we could do a bit more intense light. Well, that really, for some reason, screws up the whole thing. I have to look into the lighting calculations because I'm not sure that there's not a bug in there. Um, let's just turn it off if I can here. Yeah, this is just ambient lighting. Which looks fine. I mean, it's not pretty, but well, do we need even more scaling? I mean, it's sorta some large bricks. Let's see. Okay. Ah, okay. We definitely do not have resizing of the frame buffer or the buffer implemented. Anyway, I'm gonna play around a bit with this lighting system. What if it just points at the origin? Well, that definitely makes things a lot better, I think. Let's see. Did we disable the so if I turn off the ambient lighting here, or rather, well, am I supposed to multiply? I'm not sure I am. Let me just check this shader code. I'm not sure it's entirely correct. I have implemented a previous shader here, and I set the yeah, so we do calculate that onto it. Yeah, I think it is fine. Let's reduce this and play a bit around with the lighting mechanism here. Let's see. Let's raise it a bit. So yeah, if it doesn't get, let's put it very, very, very far away. Doesn't change anything, does it? Let's try out some extreme values. Nope. It's just maybe it doesn't like. There's definitely something wrong with this. It does look cool, somewhat at least. Um, but yeah, I'm not sure the the code is correct. Let's see. This did look a bit better. Maybe, let me see. Maybe I upload the wrong values into the shader. That could be a problem. So we have a structure like this, but what is our local renderer structure? We have the, let's see, we have the strength, we have the fall off. Mm, spot power position. So it's not because our lighting data isn't correct. Let's look into our thingy here. Uh, 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 yeah, let me see. Uh, 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 wait a minute. No, that is fine. Uh, mm, no, that's correct. Mm, that is correct. Yeah, this looks so weird. Uh, let's check out what our lighting values are inside. Uh, inside. I mean, this is definitely not the way it's supposed to look. I mean, the path buffer. Let's see, how did we structure it? Path data, object data. So did we inside our shared data, path data? Yeah, and we do it as the last component. The camera position, is that updated? Or do we not do that whenever update path data? Yeah, or path data. Oh, no. Yeah, never mind. I thought I found the error, but I didn't. But I didn't. Camera data. We are gonna, let's see. I am gonna check that we do pass in the correct data. Huh? Oh yeah. So data, our camera position is set, the delta time is set, the first one, strength, direction, position. It's all set correctly. So yeah, that's what gets uploaded. So it's probably going to be correct. Let's see. First off, a float 4x4, then a float 3, then a float, and then some other data. First we have float 3, then we have a float 3, a float, float 3, float, float 3, float. Right. Yeah, and everything does get uploaded correctly. Then I'll have to check the light thingy here because I did perhaps change a bit of it. All right, let's just test something else. Let's, instead of it being, let's see, a directional light, let's just comment this out. and set some information here. We will still use our strength of that. And let's do a direction. Let's do a position. Of and fall of start, fall of end. We're not gonna set that spot power, or rather we're gonna set that fall of start. Well, that is going to be 40. Fall of end is going to be, that's the, and we adjust the power. Let's set it to 1. Yeah, there's definitely something wrong here. Yeah, there's definitely something wrong here. Yeah. Problem might be our view projection matrix or something. It's not supposed to behave this way. Let's do 50. Does it change anything? No, it doesn't increase anything, so it's probably clamped between 0 and 1. Doesn't change anything at all. Let's see. Yeah. I think there's probably spotlight, so yeah, it's definitely not supposed to behave like that. uh, Let me just test something here. Yeah, first and foremost, let's just to be sure. Let's see. This doesn't change anything. Nope. Then we do our math. Yeah. Am I supposed to? Let's see, not that. Yeah. Let's test this. This looks so weird. Let's do calculate right hand side projection matrix. Let's see. Let's see. Um, yeah, I've been messing around with these. Mm. Let's see. Uh, okay. Let's see. Right hand sided view and projection matrix. Okay. If we flip this. It looks really, really weird. Yeah, okay. Anyway, I'm gonna bother with this a bit off stream. I think at least for now I've shown how to upload and use the textures. So yeah, I will end the YouTube video right here. Feel free to comment, like, or subscribe if you found any of this helpful.